In this video, I'm going to be talking about plate boundaries. So I'll start off with defining what a plate boundary is. So a plate boundary is basically where the area where two tectonic plates meet. So let's suppose we've got one plate here and one plate here. This region here is called a plate boundary. Okay. And there's three types of plate boundary. Okay. First one, divergent plate boundary. Okay, and each of these different types of plate boundaries is characterized by how the plates move and the geological effects which occur that result in the movement. Okay, so I'll start with divergent boundaries. So to diverge means to move apart, right? So it's very simple. When two plates move apart, that's called a divergent. What you have here is called the divergent plate boundary. And if they move apart, this means that magma from the mantle can rise. Okay, and you get things like volcanoes forming. Okay, and this rising hot magma solidifies to form new lithosphere. So you can get things like volcanoes, which look like this. Okay, and when this happens in particular between two oceanic plates, you get a mid-ocean ridge, okay, in between. And when this happens on a continent, right, you get what's called a rift valley, okay, and volcanoes, as I've shown here. And our divergent boundary is also sometimes called a constructive boundary. Constructive because you've got new lithosphere being made. Okay. So you have volcanoes forming, you've got rift valleys forming as well. Okay, so massive cracks and mid-ocean ridges. So that's divergent plate boundary. And yeah, they form between continental plates, and they can also form between oceanic plates. Okay, so in other words, on the land and underwater. Next up is, it's called a convergent plate boundary. Now, to converge means to come together, right? In the context of light, let's say when light converges, it means it meets at a point, right? So when plates come together, okay, and they collide, and as a result of the collision, they sort of rise a bit, okay? And this is how you get what's called mountains or fold mountains. Fold because it's forming in 3D. I can't really draw it here, but the pushing up is occurring in 3D of the plates because the plates are three-dimensional. You get mountains, fold mountains, okay, a chain of mountains, okay, because the crust buckles and pushes together. And with this type of plate boundary, it occurs between continental crust plates. It can occur between continental and oceanic plates, and it can also occur between oceanic and oceanic plates. Okay, so fold mountains typically form. Okay, for example, the Himalayas, that's how they're believed to be formed, or the Alps as well. You can also get volcanic island arcs, right? Which is basically a belt of volcanoes formed above a subducting oceanic tectonic plate, right? And with the belt of the volcanic arc arranged in an arc shape. Okay, so like this, for example. When two plates come together, you can get volcanic island arcs. So fold mountains, also volcanoes, can form this way. And the third type of plate boundary is called a transform plate boundary. And it's pretty simple. It's basically when two plates slide past each other. Okay, they could be going in different directions or they could be moving in the same direction. And this causes basically a break here between the plates in the Earth's surface, okay? And these regions are called faults. It's a fault, Okay, and as the plates collide and move past each other, they cause earthquakes. This is how earthquakes are commonly formed. And transform boundaries, I should also note, they're not what's called, they're actually also called conservative boundaries, because the lithosphere, the crust, is neither created nor destroyed. Okay, it remains as it is. The San Andreas fault near San Francisco in America is the most famous transform fault. Okay, and so if you're living, let's say, near a fault, you better watch out, because that's a region where earthquakes commonly occur. And basically, as the plates, they slide past each other in opposite directions or in the same direction, pressure builds up in the rocks on either side of the fault, and you've got friction taking action. Okay, and this is because the fault surface is often rough, right? Rocks are rough typically, and friction creates large strains along the faults, right? You get tears as well. And so these are the three different types of plate boundaries.